All right, ladies and gentlemen, hope everyone is doing well. We are going to go ahead and look at our review for Unit 3. And if we remember that this unit was pretty much divided into quadratics, polynomials, and rational functions. So kind of starting off, we're going to go ahead and look at our quadratic, and h of x equals x squared minus x minus 20. And we're going to be asked to find the vertex, the y-intercept, and then also the x-intercept. Since this is a quadratic and standard form, remember we had our two different versions in our standard form. That is simply that f of x equals ax squared plus bx plus c. Then we also had our vertex form, which was f of x equals a times x minus h quantity squared plus k. And that should look pretty familiar, at least that vertex form from Unit 2. But looking at our very first one, since it is in standard form, if we recall to find our vertex, we're going to use the opposite of b over 2a, comma, f of the opposite of b over 2a. And that simply means we're going to take this value and plug it in once we are finished. So looking at this to find our vertex, we know that x equals the opposite of negative 1 over 2 times 1. So then that happens to be 1 over 2, which is 1/2. So then that would be 1/2 comma something. And then what we're going to do is find f of 1/2. So then that would be 1/2 squared minus 1/2 minus 20. And I'm going to go ahead and take our calculator and just plug that in. So 1 divided by 2 quantity squared, let me move that up, minus 1 divided by 2 minus 20. And then once again, we do not like these wonderful for our decimals. We're going to go ahead and go math, enter, enter, change that to a fraction, and that is negative 81 over 4. So that happens to be our vertex of our quadratic. And then we're going to go ahead and find our x-intercept and our y-intercept. I'm going to go ahead and find our y-intercept because it's a little bit easier. So our y-intercept, if we remember with our y-intercept, the x value is 0. So that happens to be y equals 0 squared minus 0 minus 20. So y equals negative 20. And if we remember, intercepts are ordered pairs. Intercepts are ordered pairs. So that is really 0, negative 20. And then finally, we're going to go ahead and find our x-intercept. And to do so, the y value is 0. So we have 0 equals x squared minus x minus 20. And oh my goodness, we get to do my favorite thing, and we're going to go ahead and factor. So two numbers multiplied together, that's negative 20. That add to be negative 1. So that is x minus 5 and x plus 4. And so x minus 5 equals 0, x plus 4 equals 0. So x equals 5, and x equals -4. And once again, since they're intercepts, these need to be written as ordered pairs. So 5, 0 and -4, 0. And then we would typically go ahead and graph that, but unfortunately since these don't graph super nice, but I'll go ahead and kind of make a rough sketch. We would go one half, and then this would be way down here, 5, 0, and then -4. And then obviously this is going to cross somewhere way down here because 0, -20. But ultimately, it's going to look something like that. Then we had our word problems with this. And looking at this one, it says that the profit P in dollars is given by P of X equals -0.003x squared plus 180x minus 150,000. Where X is the number of units sold, what is the sales level that will yield the maximum profit? And with those, remember, all we really have to be concerned with is our function and then our phrase. So if we hear something like will yield, will produce, will give, and kind of that maximum or minimum, what we're actually looking for is that x coordinate of our vertex. If it says what is the maximum or minimum, we're looking for the y coordinate of our vertex. And that just kind of goes back to that opposite of b over 2a, or f of the opposite of b over 2a. But either way, we always have to find the x coordinate. So looking at this, since it says will yield a maximum, we're looking for the x coordinate of our vertex. So we're going to go x equals the opposite of b over 2a. So we have the opposite of 180 over 2 times -0.0003. And if we vaguely remember from class, I said be careful plugging this in our calculators, simply because if we went -180 divided by 2 times -0.0003, we're going to get two different answers. Whether we then put it in -180 divided by, and then 2 times -0.0003. And if we recall, we want that second one just so we use our order of operations. And we know that looking at this, we are going to end up with 300,000 units. So not too bad. Or if we want to just kind of skip all that, remember we can go alpha y equals to get to this, or we could put it in just like that and make our fraction without having to worry about our division. Next, so that was kind of it for the quadratics. Then we're going to look at our polynomials. And it says find the polynomial function with integer coefficients that have the following zeros. Write in factored form. So ultimately, these are all of our zeros, meaning where does it cross the x-axis, and we want to write our function. So this, as a factor, ends up being x minus 2 equals 0. This is, so far, 4x equals -3 So 4x plus 3 equals 0. And this last one would be x plus 7 equals 0. So there are all of our factors. When it says to write a function, make sure we go f of x equals, and our factors are x minus 2, 4x plus 3, and x plus 7. So this right here is our final answer. Now if we look at letter C, typo, that we have x equals negative 4 plus 3i and x equals 1. If we recall those imaginary numbers, they come in pairs. Very, very important. So just because we have this one, we also have to know x equals negative 4 minus 3i, because imaginary solutions always come in pairs. So now if we're going to write this in factored form, we're going to have x plus 4 equals 3i. So x plus 4 minus 3i equals 0. I'm going to go ahead and do this one next. So then this is x plus 4 equals negative 3i. X plus 4 plus 3i equals 0. And then this one is x minus 1 equals 0. So here are the three factors. So our function, so we're going to start f of x equals x plus 4 minus 3i, x plus 4 plus 3i, and then finally x minus 1. So far, so good with our polynomials. So looking more at some of our polynomials, the next one we have says given our function f of x, 3x to the third minus 5x squared plus 28x plus 10. And with first thing it says list all possible rational zeros. So first of all possibles means that we're going to have to figure out what is P over Q. And if we recall, back here, our constant is P, and our leading coefficient is Q. So all of our factors of P, so 10, would be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. All of our factors of Q, so possible factors of 3, plus or minus 1, and plus or minus 3. So then if we're going to find P over Q, we're going to come up with all of our combinations. So 1 over 1 is 1, so plus or minus 1. 2 over 1, plus or minus 2. 5 over 1, plus or minus 5. 10 over 1, plus or minus 10. Then our next one, 1 over 3, so plus or minus 1/3. 2 over 3, plus or minus 2/3. 5 over 3, plus or minus 5/3. And finally, 10 over 3, so plus or minus 10/3. Then it says, use this information to find all zeros of the polynomial function. So this is when we're going to go plug this in our calculator. And we're going to just go to y equals, and we're going to go 3x to the third minus 5x squared plus 28x plus 10. And we're going to hit graph. And we're going to see where does that cross. And I'll just kind of give us a hint. We could also look at our table But one of the things we're going to notice, we can't find a 0, so we know it is going to have to be a fraction. And like I mentioned, to kind of give you a hint, it is going to, in this case, be negative 1/3. So negative 1/3 goes in this little backwards L, and we're going to do synthetic division. So we have 3, negative 5, 28, and 10. Bring down our 3. So negative 1/3 times 3 is negative 1. Add these up, so negative 6. Negative 1/3 times negative 6 is 2. 30. Negative 1/3 times 30 is negative 10. And since it's a 0, we should have a remainder of 0. And now, since this was a cubic, what we are left with is a quadratic. So we have 3x squared minus 6x plus 30 equals 0. And from here, we can try to factor. One of the things we could potentially notice is we can factor out a 3, and we are left with x squared minus 2x plus 10 equals 0. But if we try to factor this part right here, we're going to notice it does not. We have two options. We may complete the square, or we can use the quadratic formula. I'm going to go ahead and use the quadratic formula, and if we remember, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I have a hard time not singing the quadratic formula song in my head when I'm doing that. So x equals the opposite of negative 2 plus minus the square root of negative 2 squared minus 4 times 1 times 10 all over 2 times 1. So x equals 2 plus or minus the square root of, and then we can plug that in our calculator, but that would be 4 minus 40, so that is negative 36 over 2. So x equals 2 plus or minus, and then that would be 6i over 2. And now don't forget to kind of split that up, so that is 2 over 2 plus or minus 6i over 2. So 1 plus or minus 3i. So then it says find our zeros. So we can kind of just write and say that our zeros, that x equals negative 1/3. Don't forget about the one we used in our synthetic division, and x equals 1 plus or minus 3i. So here is our final answer. And then number 8 is, sorry, wow, big typo, 5 to 8. But no, the next one happens to be done the exact same way. But notice we are no longer starting with p over q. And it says find the zeros of our function f of x equals x to the fourth minus 10x to the third plus 25x squared minus 52x plus 28. So first place we're going to start, we're going to put this in our calculator. So we have x to the fourth minus 10x to the third plus 35x squared minus 52x plus 28. And we're going to go ahead, and hit graph. So here's our function. Kind of looking at, kind of sort of looks like it is going through 2. So we can look at our table and we're going to notice 2. Oops, there we go. 2 does give us a nice little 0. So we're going to go ahead and put 2 in our backwards L, and we're going to go with our synthetic division of 1, -10, 35, -52, and 28, and bring down our 1. So 2, -8, -16. Add those together to get 19. 2 times 19 is 38. -52 plus 38 is -14. And then here we have -28. And we have a remainder of 0. But if we kind of look strategically, we're going to notice we don't see another 0. What this happens to have, if we recall, is something called a bounce. Meaning if we look at our graph, it, believe it or not, kind of comes down, touches, and kind of shoots back up in the other direction slightly. So that simply means we're going to have to use 2 again, since it has that bounce. And we're going to bring down our 1. So then 2, then -6, -12, 7, 14, and then 0. So now we have a quadratic, and our quadratic is x squared minus 6x plus 7 equals 0. And once again, we have our 2 options. Do we want to complete the square, or we could try to factor, but we're going to notice it doesn't, or we can go ahead and just use the quadratic formula. I'm going to go ahead and just use the quadratic formula since we have it up here on the page. So x equals the opposite of -6 plus minus the square root of -6 squared minus 4 times 1 times 7 all over 2 times 1. So we have 6 plus or minus, and then that ends up being the square root of 8 over 2. Simplify your radical. So 6 plus or minus 2 square root of 2 over 2. And don't forget to kind of split your terms up. So 6 over 2 plus or minus 2 square root of 2 over 2. So 3 plus or minus the square root of 2. And then kind of looking, remember we are wanting our zeros. So we know x equals 2, but since it appears twice, it has a multiplicity of 2. And then we have 3 plus or minus the square root of 2. Those happen to be all of our zeros, which makes sense because we would expect 4 answers because it is to the 4th. Just like on the problem above, it was x to the 3rd, and we should have 3 zeros of some sorts. And finally, the last thing that we were asked to do with this unit was to graph our rational functions. And with this, we have different rules that we have to remember. Our x-intercepts, y-intercepts, then we had vertical and horizontal asymptotes. That x-intercepts and y-intercepts are found just like they were before. X-intercepts, that our y value is 0. Our y-intercept our x value is 0. So just like with our quadratics at the beginning of this unit, the one thing that would be that our asymptotes pretty much are going to dictate everything, as well as our domain. Our vertical asymptotes, if we remember with those, has to do with our domain, and all we're going to do is set our denominator equal to 0. So let's go ahead and find all of our asymptotes first. So we have our function f of x equals 4x minus 7 over 3x plus 1. So first thing we're going to do, find our vertical asymptote, which would be that 3x plus 1. And we know we can't divide by 0, so it cannot equal 0. So then we have 3x, and I'm going to just go ahead and say equals, since it's actually an asymptote, equals negative 1, x equals negative 1/3. So we would say our vertical would be x equals negative 1/3. And remember that asymptotes are equations. So for that vertical, we're going to go ahead and mark some of these off. So negative 1/3 approximately over in here. The one that's a little more challenging to find happens to be our horizontal. And with that, if we remember, we had different rules. That if the degree of the numerator is less than the degree of the denominator, it is at y equals 0. If the degree of the numerator equals the degree of the denominator, then we're going to look to the ratio of their leading coefficients. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote, and then we end up with something called a slant, and then we're going to use long division to find that. So looking at this, the degree of our numerator is 1. The degree of our denominator is also 1. So since our degrees are equal, we're going to look at our leading coefficients. So it becomes y equals 4 over 3. So our horizontal, y equals 4/3. So that is 1 and an additional third. So about something like so. Well, now we're going to go ahead and find our x and y intercepts. So our x-intercept, if we remember, our y value is 0. So we have 0 equals 4x minus 7 over 3x plus 1. I'm going to put that over 1. Find our cross product. So 4x minus 7 equals 0. 4x equals 7. X equals 7/4. And once again, intercepts are ordered pairs. So 7/4, comma, 0. So that would be 1 and 3/4. So 1, so about right there. And then our y-intercept, our x value is 0. So for our y-intercept in this case, we have y equals 4 times 0 minus 7 over 3 times 0 plus 1. So y equals negative 7. So then that is 0, negative 7. So we're out here somewhere. And I just graphed that right. 0, negative 7. Let me redo that. 0. Let me add some extra lines here for a second. So 0, negative 7. So disregard that. I don't know what I was thinking right there. 2, 3, 4, 5, 6, and 7. Brain hiccup at that present moment. And you can't even see it on the screen. So I don't feel quite so bad. And we can go ahead and graph this. We can go alpha y equals and put it in like so. So this happens to be 4x minus 7 over 3x plus 1, and we're going to hit graph. And then just make a nice little sketch as follows. So we're going to go like so, and then like so. And if we happen to look at the second one on here, ultimately it is done the exact same way. Oh, I'm sorry, I forgot our domain. Remember going from left to right. Notice our graph is in two pieces, so we're going to have two pieces with our domain. And our domain always is going to follow that vertical asymptote. So our domain goes from negative infinity to negative 1/3, union negative 1/3 to positive infinity. And finally, our last one, done pretty much the same way. We're going to go ahead and find our vertical asymptotes and then our horizontal. So looking at that, we have x squared plus 2x minus 3 over 2x squared minus 8. So if we're going to find that vertical asymptote, we have 2x squared minus 8 equals 0. Factor out a 2. So x squared minus 4 equals 0. So then that is x plus 2, x minus 2. So x equals negative 2 and x equals positive 2. So in this case, we now have two vertical asymptotes. So negative 2 and positive 2. So if we looked at our horizontal, once again we're going to look at our degrees. This one has a degree of 2. And this one also has a degree of 2. So that simply means that our horizontal is going to be at y equals 1/2. So it is about right in here. I know you guys didn't like these types of graphs. I kind of miss my full-fledged ones as well. So next we're going to do x-intercepts and y-intercepts. So our x-intercept ends up being 0 equals x squared plus 2x minus 3 over 2x squared minus 8 over 1 cross product. So 0 equals x squared plus 2x minus 3. And we're going to go ahead and factor that. And that is x plus 3, x minus 1. So then our intercepts are at negative 3 and then positive 1. So our x-intercept is then negative 3 comma 0. And then it is going to be at 1 comma 0. So x-intercept 1 comma 0 and negative 3 comma 0. And if we look here, our y-intercept is simply plugging in 0. So it is going to be at 3/8 because it ends up being negative 3 over negative 8 because we're just plugging in 0 for x. So 0, 3/8. So we are up here just ever so slightly. Okay? And then we can go ahead and plug this in to our calculator. I'm going to go ahead and go alpha y equals, so I can put my little fraction in, and we have x squared plus 2x minus 3 over 2x squared minus 8. And I'm going to double check, did I put everything in right? And then hit graph. So here's our lovely little graph, and notice our function is divided into 3 different parts. So that being said, our domain also has 3 different parts. And once again, that domain gets separated by our vertical asymptotes. So our domain is dealing with those vertical asymptotes. So it is going from negative infinity to negative 2, left to right, union negative 2 to 2, and then finally union 2 to positive infinity. And that is it for Unit 3, ladies and gentlemen, in a nutshell. Next video will be Unit 4. Have a great day. Bye.